All right, chapter 7 in class multiple choice review. Here we go. Number 1 is getting a do you know the difference between a parameter and a statistic? Furthermore, it's talking about a percent. So always keep your cheat sheet handy. It usually is narrowing in on one or two of these boxes. In this case, it's getting to here. Do you know that statistics come from samples and that parameters come from the population? So P's are parameters, P hats are statistics, okay? So back to the question. The orange number is the sample size from the study. So it created a 72% answer. So it is a statistic because it came from a sample. So that would be 72% is a statistic. P hat. The 56% came from election records, which is the population. That's the records of everyone in the city and if they voted or didn't vote. So that's a parameter. So the answer is C. 2. The Gallup poll increased the size of the sample from 1,500 to 4,000. The effect of this increase in sample size is to do what? You have answers about bias and variability. Variability is spread. You should immediately think of standard deviation and look for this formula on your cheat sheet right here, because proportions, standard deviation, boom, right there. And then think to yourself, the only difference here would be 1,500 versus 4,000, right? I wrote it sideways. Increasing sample size always reduces standard deviation because I'm dividing by a larger number than I'm dividing by over here. So it reduces variability. So it is either C or E. Okay. Does it also reduce bias? The answer is no. Because if a collection method is biased, increasing how many people you ask, increasing sample size will not fix that. For example, if my method is to only ask females and not ask any males, I'm leaving the males out. That's biased. If I ask more females than I did, I'm still not asking any males. Okay? So it's still biased. Increasing sample size does not fix bias. So it is C. Number 3. My sample size is 100. It's a proportion. Okay, I'm scanning for those important things. For what value of P is it safe to use the normal approximation? So, cheat sheet, it's a proportion. How do I know it's normal? Ding, 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 ding. This box right here. Large counts. I need to do that formula on these options until I find the only one that gets 10 and 10. And the only one that works is when you have 85%. If you tried 1%, 9%, 97.5, or 99.9, it wouldn't work for both of these to be at least 10. 4, the central limit theorem. Cheat sheet, right here. This is for a sample mean when you want to know if it's normal. And it simply says the sample size has to be at least 30. Okay? That's all it really says. So it says the CLT allows us to say it's normal, to use a normal distribution, if what? The answer is A. If your sample size is sufficiently large, sufficiently is the cutoff of 30. For any population, so let me just address this for a second. It does not matter what the shape of the population is. The population can be normal, can be skewed left, skewed right. It doesn't matter, folks. As long as you sample 30 items from these populations, the resulting sampling distribution, this is what we care about. The resulting sampling distribution will be normal. Okay? So that rules off B and C and D. And the CLT is not talking about population size. It's talking about sample size. So it's not E. 5. This is comparing the two schools, Johns Hopkins and OSU. OSU is massive. It's maybe one of the largest schools. And it says the sample is 3% of both schools. So I did down here 3% for OSU and 3% for Johns Hopkins. So these are the sample sizes. So it's a much bigger sample at OSU. And what did we just learn up here? Increasing sample size reduces standard deviation. But if you don't remember that, you can still calculate it. It says, suppose that P equals 0.80 at both schools. So when I do the formula, 0.8 times 1 minus 0.8 over 1800 versus 0.8 times 1 minus 0.8 over 60, you get this to play out in real time. So square root of 0.8 times 1 minus 0.8 divided by 1800 kids in the sample. Oops, I don't want that parenthesis. And you get 0.0, very small. Then if you go up here and replace the sample size with 60 for Johns Hopkins, you get a bigger number, 0.05, okay? So how does this matter with the answers? All the answers are talking about the estimate will be closer to the truth. The estimate will be closer to the truth over and over and over again. Which school will have estimates closer to the truth? Well, it's the one that has a smaller variability. It's OSU. OSU will be closer to the truth. Okay? They won't be about the same distance. We just proved right here they're not the same. So it's not A and B, and it's not E. So it's C or D. Is it closer to the truth because it came from a larger population? Because the school itself is bigger? Or are our estimates closer because our sample size is larger? Well, the formula is based on N. And what's N? N is sample size. It is not based on the population size. Standard deviation here is based on sample size. So it's D. 6, a researcher plans to take a random sample of 160 from a population and calculate the sample mean. Later, the researcher decides to increase the sample size, so the standard deviation of mu will be half as big as what it was. What sample size should they use? Look, folks, you can cross off A and B because it says increase. If it started at 160 and you're increasing it, look at those freebies, just get rid of A and B. So it's either C or D. What formula are we going to use for standard deviation? Well, cheat sheet. It was a sample mean, standard deviation right here. Sigma over root n. Now, the problem is it does not give you sigma, so why don't you just make one up? You can pick anything you want, 100, 200, 500, 8 million, I don't care. It doesn't matter. So then just test these two. What is 100 over, first of all, what's 100 over the square root of 160? Because that's the original sample size. Calculator. 100 divided by square root of 160. So that's the starting one, 7.9. Okay. That's about 8. So I need to change it to about 4. Will that happen if I make the sample size 320? That's the answer to C. No. Will that happen if I change it to 640? Oh, look at that. That's the one. So the answer is 640. Okay. 7. We have a large university takes a sample of 250 people, asks them, do they favor something, eliminating the carnival? In the sample, 150 of the 250 were in favor. So this information here is a statistic. It came from a sample. If you divide it, you get 0.60, which does happen to be these two numbers down here, so keep that in mind. The 55% here is all the undergrads, so that's a parameter. So again, keeping those straight. Because notice half the answers have the parameter and half the answers have the statistic. What is the question? If you took a very large sample a very large number of simple random samples. The sampling distribution would be what? Would it be exactly normal? Run away! It's never, ever exactly normal. Never. Well, is it at least approximately normal? Well, it's a proportion. So it's large counts. It's on your cheat sheet. And you do n times p. N is 250. And you do p. And that'll give you 137.5 when you do this. And then 1 minus p. You get numbers that are both at least 10. So it is approximately normal. So it's not heavily skewed. So it is either B or D. So is it have a mean or a center of 55 or a center of 60? Sampling distributions are always centered at the parameter of 55, not at 60. So the answer is B. 3 more. Which of the following statements is incorrect? Well, A, B, C, and D are true. So the answer is E. Why is A true? The standard deviation will decrease as sample size increases. We said that exact same thing twice higher up on this. B, the standard deviation of the sampling distribution measures how far the sample mean typically varies from the mean. So the standard deviation is how it typically varies from the mean. That is exactly how we interpret standard deviation. C, the sample mean is unbiased, meaning, sorry, I'm jumping around, but unbiased means that half the dots are above the parameter and half the dots are below the parameter. That is true when we've done this in class with the power forwards or the shooting guards. You each got a sample mean, you put it on the whiteboard, and our distribution was unbiased. The parameter was in the center, so that's true. D is also true. The sampling distribution shows how the sample mean is distributed around the parameter. Sampling distributions are centered on the parameter, the population mean. It is not centered on the sample mean, which is what part E is saying. This is why part E is wrong-o, which ironically makes it the right answer. 2 more. Number 9. This is about babies that weigh less than 1,000 grams. They had a sample of 219 kids, so that's N. And it had an X bar, their sample did, so that's a statistic. Their sample average was 810. The sample mean is an unbiased estimator, which means what? Well, first of all, C and D are both correct answers. They're both true, but they are not talking about what it means to be unbiased. Oh, that's nasty. That's not fair. They are distractions to the highest. These are both true statements, but they do not answer the question. So sad. Okay? It's not E either. Okay? Because bias is not that the person measuring it is screwing up. Okay? It's that bias is when there's undercoverage in a method. Okay? Like I talked about earlier, only asking males or only asking females. That's not what E is saying. So it's A or B. It says in all our possible samples, the mean, when I see the word mean, I think the center of all of my samples, the center of all of my X bars, will it be 810 or will it be the parameter? And I just alluded to it again. Sampling distribution center on the parameter. So it is not A, it is B. Last one. You're getting paid by flipping a coin. If it lands heads, you get $80. Tails, you get $40. You took a simple random sample of 2, only 2. N is 2. So the shape of this distribution, when your sample size is 2, have you met the CLT? Nope. So is it approximately normal or normal? Nope. It's not normal, so the answer is E. But why is it symmetric? Because flipping a coin to determine if you get 80 or 40 would not give you skewed results, right? You've got 80 over here and 40 over here. The middle would be 60. I'd say, you know, sometimes you're going to be over here at 80 when you land on heads, and sometimes you'll be at 40 when you land on tails. But the coin will make it symmetric. It will not be right skewed or left skewed. That's all, folks. Bye-bye.